Hello everybody, this is the notes for the second part of section 8.5 for Algebra 2 Trig, talking about solving rational inequalities. Alright, so you see that first equation, the x plus 1 over x greater than negative 3. That's the one that we solved in class using the method of using the different cases. If x was positive or greater than 0, or if x was negative, being less than 0. And that created a couple of different cases that we just went through and solved. Okay, that's the real logic behind solving these inequalities. But there's an easier way to do it, an easier way to deal with it that will always work. But you got to do a couple of different things to get that. So that's what these notes are up top here. So this will always work. What you got to do, identify any values of the variable that would not, or that would make the function undefined. So basically, domain. So looking at where we've done this function, let's look at the x plus 1 over x minus 1, this second equation here. All right, x cannot equal a positive 1 from the first denominator. X cannot equal 0 from the second fraction, the 2 over x. And that's our only restrictions on the variable. Okay, so we need those numbers. We're just going to set them there for a little bit. The second step says replace the inequality symbol with an equal sign and solve it. So now it's just an equal sign. So now we're just solving this rational equation. All right, to do this, I'm going to multiply everything by that least common denominator, which in this case is going to be x minus 1. So when we do that, every single term gets multiplied by those two factors. The first term, the x minus 1s are going to cancel out. We're going to be left with x times x plus 1. And we got plus. All right, the second term, the 2 over x. The x's will cancel out, leaving us with 2 times x minus 1 equals, and we just got x times x minus 1. So now we just need to solve this. So cleaning this up a little bit, distributive property, combining like terms, all that business. X squared plus x plus 2x minus 2 equals x squared minus x. Okay, we got the different powers of the variables, so we're going to move everything to one side. I'm going to subtract x squared here. Those go away. How convenient. Now we've only got one power of x. It's just a linear function. So let's move all those x's to one side of the equal sign. So I'm going to add x here. So I got 1x plus 2x, which is a 3x. I'm adding another x. So that's going to give me 4x. And then I'm going to add this 2 to the other side, which just gives me 2. So now to solve for x, divide by 4. X is 1/2. Okay. So we took care of the first step. We had our restrictions. That's these two numbers. We took care of the second step. We replaced the inequality with an equal sign. We solved it. And that gave us the 1/2 value down here. Now, those are not our answers. So now we're on to the last step, to figure out the answer to this inequality. Okay? It is not an equal sign. We are solving that greater than or equal to. It says, the third step, place all the values you found above onto a number line. So what we are looking at, number line, we have 0, we have 1/2, and we have 1. Okay? It is dividing that number line into 4 regions. X value is less than 0. X value is greater than 0, less than 1/2. X value is greater than 1/2, less than 1, and x value is greater than 1. What we need to do says we place the number line, or all these values under a number line, test intervals to see which satisfies the original inequality. Okay, so what we're going to do, pick a number in each interval. So less than 0, I'm just going to pick the easiest number, -1. I'm going to plug it in. So I'm going to do all my work over the side here. Plugging in -1. We're going to get 0 over -2 plus 2 over -1. Is that greater than or equal to 1? So 0 plus a -2, which is -2. -2 is not greater than 1. Since -1 didn't work, none of those are going to work. Okay, keep on going. Pick a number between 0 and 1/2 in that next interval. So 1/4. All right, to do that, 1/4. So I'm just plugging 1/4 into our equation. 1/4 plus 1 is 5/4 over 1/4 minus 1 is a negative 3/4 plus 2 over 1/4. Is that greater than or equal to 1? All right. Dividing by a fraction, we multiply by the reciprocal, so we're going to get 5 over negative 3 plus 2 times 4 is 8. Is that greater than or equal to 1? You bet it is. Since 1/4 worked, all of these are going to work. Okay, now that's not exactly our answer. We've got a couple other little things to think about, but we know we're going to have at least that part of our answer. There's just a little detail to come back to. And like I said, we'll come back to it. Next interval, I'm going to plug in 3/4. You got to test all of these intervals. Just to keep everything on the board here, plugging in 3/4. So 3/4 plus 1 is a 7/4. 3/4 minus 1 is a negative 1/4. So that's going to be a negative 7 plus 2 over 3/4 is going to be an 8/3. Is that greater than or equal to 1? No. No, it's not. So if 3/4 didn't work, none of those are going to work. Now, last interval, number greater than 1, pick 2. So plugging in 2, we're going to get 3 over 1 plus 2 over 2. Is that greater than or equal to 1? 3 plus 1 is 4. That is greater than or equal to 1. Because 2 worked, all of these numbers are going to work. All right. The last bit is taking care of just tiny little details. We are solving an or equal to equation. So when we got this 1/2 down here, if you just carried that symbol all the way through, the greater than or equal to symbol all the way through, that or equal to sticks with the 1/2. Now, as far as the 0 is concerned, x greater than 0, remember, x cannot equal 0. So we are not going to put an or equal to with the 0 relating it to the x value. So this is our part of our answer. The other interval was x greater than 1. Remember, x cannot equal 1. So we just leave that, x greater than 1. So we have two different intervals. Technically, there's a little or statement in between there, but this is our answer. Okay? If we didn't do this process with a number line and did the work that we just talked about in class with the different cases, this problem will become much more complex. It can be done because it's the logic of the inequalities, but it's much more complex. So this method, it's always going to work, and it takes care of a lot of the iffiness that comes with these inequalities. Okay? You identify your domain, any restrictions, you got to have those numbers. And then you replace the inequality with an equal sign and solve it like normal. Take all of those numbers, the restrictions and those values that you solve for, throw them onto a number line, it creates all those intervals, you test to see which ones work. And there's your answer. It works every single time. Now, just as a check, here's the graph of our two functions. All right, we're looking at the bottom two equations. You see there's 4 equations there on the left. I'm looking at the bottom 2, but they're graphed here. All right, we got our original problem was we want to be greater than or equal to 1. So this green line, that's y equals 1. So we want to be above that. You can see right in, whoa, didn't want that. You can see in this space up here, we're above 1. All right, we have a vertical asymptote at 0. So all these x values in between 0 and this is 1/2. Oops, it doesn't work. How do I get rid of that? Between the 0 and the 1/2, our function is greater than 1. We also have a vertical asymptote here at 1. All these x values greater than 1. Our function is above the y value of 1. So it's just a visualization to confirm our answer. But these 3 steps that you see here, these are how you can do all of these inequality problems. Bye.